All right, number 11, we're asked to determine whether the equation has a graph that is symmetric with respect to the y-axis, x-axis, the origin, or none of these. And we've been given the equation y equals negative 5x to the fifth minus 6x cubed. And just like with number 10, we're going to perform 3 separate tests to determine whether or not this graph is symmetric with respect to the x-axis, whether it's symmetric with respect to the y-axis, or whether it's symmetric to the origin with respect to the origin, or maybe it's none of these. I don't know. Let's find out. So let's perform the x-axis symmetry test first. So x-axis symmetry. And you can see over here to the right, I've put 2 separate charts, 2 boxes here, and these come directly from your textbook, pages 245 and 246, and these are the 3 separate tests that we are going to perform to determine symmetry. And we can see here off to the right that the graph of an equation is symmetric with respect to the x-axis, and that's what we're doing. We're testing for x-axis symmetry. So the graph of an equation is symmetric with respect to the x-axis if the replacement of y with negative y results in an equivalent equation. So all we're going to do is take the original equation that we started with. So in this case, y equals negative 5x to the fifth minus 6x cubed. And they tell us to replace y, so replace y with negative y and see what happens. So let's get rid of the y that was originally there and plug in a negative y. Let's clean this up and see what the resulting equation looks like. There's nothing here on the outside of this set of parentheses that we can distribute to change the sign of this y. It's going to remain a negative, so we can go ahead and just drop those parentheses, and that'll give us negative y equals 5x to the fifth minus 6x cubed. And because the original equation had a positive y, let's go ahead and multiply our whole equation here by negative 1, so that negative 1 times negative y gives us positive y, and negative 1 times negative 5x to the fifth, positive 5x to the fifth, and finally negative 1 times negative 6x cubed gives us plus 6x cubed. And now that we've cleaned up our equation as much as we can, we've simplified, we can't go any further, we're going to take a look and ask ourselves, is the equation that we ended up with down here the same as this equation that we started with? Is it equivalent? And we can see that it's not the same, right? We've got some sign changes. We started with y equals negative 5x to the fifth minus 6x cubed, but now we have y equals positive 5x to the fifth plus 6x cubed. So definitely some sign changes here. We can see these 2 equations are not the same, and therefore we're going to say no, the graph that we've been given is not symmetric with respect to the x-axis. If it was symmetric, the equation that we ended up with down here would have to be identical, the same as the equation that we started with. Because it's not, it is not symmetric with respect to the x-axis. All right, I'm going to go ahead and erase this work, so if you need to pause to write this down, go ahead, or of course you can always rewind. Let's test now y-axis symmetry, see what happens. And again, if you read to the right here, we can see that the replacement of an equation is symmetric, or rather the graph of an equation is symmetric with respect to the y-axis if the replacement of x with negative x results in an equivalent equation. So this time we're going to take the original equation that we started with and swap out each x for a negative x, clean up the equation, and see what happens. So let's do that. So y equals negative 5, and we're going to swap out the x that we started with a negative x to the fifth minus 6, and again swap out that x for a negative x cubed. Let's clean this up, see what happens. So we have y equals negative 5, and a negative number to an odd exponent is still negative, minus 6. A negative number, negative x, a negative number to an odd exponent, still negative. And let's clean this up for the final time. We're going to distribute that negative 5 and then distribute that negative 6. So we have negative 5 times negative x to the fifth. Well, a negative times a negative is a positive, so we end up with 5x to the fifth. And again, a negative times a negative will end up with a plus 6x cubed. And now that we've cleaned up our equation as much as we can, we're going to ask ourselves, is the original that we started with the same as what we ended up with? And again, we can see that it is not the same. These are not equivalent equations. And so therefore, we can say no. The graph that we were given, y equals negative 5x to the fifth minus 6x cubed, is not symmetric with respect to the y-axis. All right, the equation we started with is not the equation, same equation that we ended up with when we swapped the x for negative x, and so we do not have y-axis symmetry. All right, last but not least, let's test for y-axis, or rather origin symmetry. So origin symmetry. All right, and again, we can read here to the right, the graph of an equation is symmetric with respect to the origin if the replacement of both x with negative x and y with negative y at the same time results in an equivalent equation. So now we're going to swap out the y for negative y and the x's for negative x at the same time and see what happens. So swap out that y for negative y equals negative 5. Swap out the x for negative x to the fifth. Minus 6. Swap out the x for negative x cubed. And let's clean this up and see what we get. Well, there's nothing on the outside of this set of parentheses to distribute, so that means this negative y will remain a negative y. We can just drop those parentheses. So negative y equals negative 5. And then a negative number to an odd exponent is still negative. And a negative number to an odd exponent, still negative. And we can clean this up once more by distributing. So we end up with negative y equals negative times negative gives us 5x to the fifth. Negative times negative gives us plus 6x cubed. And let's go ahead and get ourselves a positive y. So we'll multiply this whole equation by a negative 1. And when we do that, we have negative 1 times negative y gives us positive y. Negative 1 times 5x to the fifth gives us negative 5x to the fifth. And finally, negative 1 times positive 6x cubed gives us negative 6x cubed. And now that we've simplified, cleaned up our equation as much as we can, let's ask ourselves for the final time, is the equation that we ended up with after we replaced y with negative y and x with negative x, is this equation the same as the equation that we started with? And we can see that it definitely is, and so therefore we can say that yes, this graph that we were given, y equals negative 5x to the fifth minus 6x cubed, does have origin symmetry. It is symmetric with respect to the origin. All right, so there are your three tests to determine symmetry. Definitely commit them to memory. They will come in handy, not only in this class, but going forward. All right, so there's number 11. Let's take a look at number 12. I'll see you there.